linear programming problem, or we simply say LPP. Okay, so this chapter falls under section C again, and it will carry 6 marks. Okay, so usually one question for 6 marks from this linear programming problem. Okay, so what is a linear programming problem? To understand this, we need to understand certain target based situations. Often in life you come across with target based situations. So what are these? Example, let's say case 1 would be you need to complete your mathematics project. Let's say mathematics project within 10 days. Another situation could be a shopkeeper has to sell certain amount of goods, maximum amount of goods, let me put it this way, maximum amount of goods in 1 month. The third scenario could be you need to buy a smartphone, let's say smartphone within 10,000. Okay, so these are the 3 situations that we have. Okay, case 1, case 2 and case 3. So what do you see here is in these 3 situations, a certain target has to be achieved in all these 3 scenarios, in case 1, case 2 and case 3. So in order to fulfill this, like for example in case 1 you need to complete your project within 10 days. In case 2 the shopkeeper has to sell maximum amount of good within 1 month, and in case 3 you need to buy a smartphone under 10,000. Okay, so let us first understand what is the objective in all these scenarios. What is your objective? Had you been in this scenario, what would be your objective? In case 1, what is your objective? In case 1, my objective is to complete the project within 10 days. So I need to complete within 10 days. That would be my objective. Okay, in case 2, maximum goods article in a month. And in case 3, buy a smartphone, let's say under 10,000. So if these are the different objective, 3 objectives you have under case 1, case 2 and case 3, there should be, let's say, in order to complete this objective, there must be some limitations or restrictions. Let me put it that way. There can be some limitations or restrictions, limitations. Okay, you may come across some limitation, like what is the restriction, limitation in case 1? What is your restriction or what is your limitation? What is the condition in case 1? The condition is time, restriction is time. You have only 10 days of time. What is your restriction in case 2? The restriction in case 2 is also time, because you have only a month. What is the restriction in case 3? The restriction in case 3 would be money, because you have a certain amount of money, only 10,000. So this is what we called target based situations. In our day-to-day life, we often come across with target based situations. So I have given an example of 3. So these type of problems in mathematics is known as optimization problems. What are these known as? Optimization problems. Let me write it here. Optimization problems. So when we convert these type of situations into mathematical problems, they are known as optimization problems. What is the meaning of optimization? Optimization would mean to achieve up to greatest extent. Maybe like you may say you have to sell maximum amount of goods, or you have to reduce the price. Okay, so these are the these are the in this type of sums you need to optimize. To optimize would mean maybe to maximize or minimize, but up to what extent is possible. In order to maximize, up to what extent can you maximize? If you have to minimize, then up to what extent can you minimize? Okay, so whether on the higher side or the lower side, you have to go towards the greatest extent, okay, maximum possible. Okay, so those type of problems are known as optimization problems, and these optimization problems you see here can be solved in mathematics by linear programming. So this linear programming is a method of solving optimization problem in mathematics. Okay, so the first introduction would be, why is LPP or linear programming what is a linear programming problem, or you may say, what is linear programming? Let me simply put it this way: linear programming is one of the method in mathematics to solve optimization problems. Okay, so to achieve a maximum profit maybe in a business, or to achieve minimum cost in a business, because if you have a business, you would always want maximum profit and a minimum cost. At a minimum cost, a consumer would want a product in at a minimum price possible, whereas the shopkeeper would want to sell a product and get maximum possible profit. Okay, so these type of sums can be optimized in order to get maximum profit for the shopkeeper. What quantities should be sold? Okay, so this linear programming is a method of a method for solving optimization problems. Okay, so let's come to the definition now. So what is the definition of linear programming problem? So let's see the definition. The definition says, an LPP is a mathematical technique to find the optimum, maximum or minimum. As I told you, optimum would mean up to a greatest extent of a linear function of two or more variables subjected to a set of conditions or constraints. In order to obtain the objective that I talked about earlier, there are always limitations here. Okay, there are always limitations that you have to face. So under certain conditions, okay, what is the objective to be achieved? That is known as that is what is called a linear programming problem. Those type of problem. Okay, it is a mathematical technique. Got it? Okay. So now let me come to few important words. So as we know, linear programming problem. Okay, now what is programming? Programming would mean planning, simple, very simple, planning or making a plan of action, you may say, making a plan, same meaning. What is it? Why is it called linear? So this is very important. Why is it called linear? Later part of the theory you would also understand this, but we call it linear. In mathematics, linear would mean having degree 1 degree, having degree 1. Okay, for example, x plus y equals to 5. This is a linear equation in two variable because the degree is 1. Okay, so why we call linear is the equation that we obtain in this chapter to when we form a linear programming problem would have degree 1. So mostly it would be simultaneous, something like a simultaneous equation. Okay, linear equation in two variable. That's why we call it linear. Okay, so now having understood this, now we need to understand how does a LPP look like, model of an LPP. Finally we come to a to the model or structure of an you may say of an LPP. Okay, you have already written all this theory. I hope you have copied this. So here we are just trying to understand whatever we have written. Okay, so let's come to the model or structure of an LPP. Having understood what is an LPP, we finally come to what is how does a LPP, how does an LPP look like. Okay, so this is what we say here. So optimize, this is how a LPP would look like. Optimize, maybe maximize or minimize. Okay, I'm just writing it right now. So z equals to c1x plus c2y. Okay, let's name it equation 1, subject to a11x plus a12y and it may have less than equals to and more than equals to. If you are confused, it can be any of these three symbols. It can be any of these three symbols. That's why we have these three symbols here. B1, a21x plus a22y, again less than equals to or more than equals to B2. And similarly, likewise, we have n number of equations, an1x plus an2y, and less than equals to or more than equals to B3. There can be any number of such equations. Okay, so and finally we have let me put it in different color here, blue. So x greater than equals to 0 comma y greater than equals to 0. So these as 2 and these as 3. Okay, so that's what we have. Okay, great. So let's minimize this a little. Great, you see the modular structure of an LPP. So in an LPP, what do we see is we have three different parts of an LPP. Clearly you can see here, this is equation 1 here, 2 and 3. So we have three parts of an LPP. What are these three parts? Let's define one by one. Number one, so this equation number 1, the linear function that you see z, the function z, okay, z is called the objective function. What is it called, everyone? Is called the objective function. Why? Now let's see, why is it called objective function? You know, in a target based problem, there is always an objective to be achieved. So in this sum also, if you see here, you have to optimize this particular function, equation number 1. This z can be profit, it can be sales, it can be cost, anything. Okay, so z can be anything. Either you have to maximize it or minimize it. So z equals to c1x plus c2y. It is expressed in terms of x and y. So the first and foremost, equation number 1, there will be your objective function, something that you have to maximize or something that you have to minimize. Okay, then all these number 2, if you see here number 2, all these inequations or equations, I may say inequations or equations, it can be anything, because if there is a equals to sign, it is called equation. If there is a inequals to sign, these ones, then it is called inequation. Okay, so it can be either equation or inequation. All these inequations are called linear constraints. What are these called, everyone? Linear constraints. You can look at your notes that you already have. This is known as linear constraints. It can be equation or inequation, and it is called linear constraints. Okay, and finally the third one here, the third one that you have here, it may look a little insignificant, but in fact it is very important here. X is greater than 0 and y is greater than equals to 0 is called non-negative restriction. What is it called, everyone? Non-negative restrictions. So here you have the model or structure of an LPP. So finally, what do we conclude is an LPP is a mathematical technique to find maximum or minimum of a linear function. Okay, whenever we have target based problems, a word problem would be given to you. You need to convert that target based problems into a linear programming problem. How does a linear programming problem look like? Linear programming problem will have three parts. That's the objective function, the linear constraints, and the non-negative restriction. So every time you get a sum based on linear inequation, you need to convert it into three parts. You need to find first of all the objective function, then you need to make all those constraints that you have, and finally you need to decide the non-negative restriction. Okay, so that is how a structure of or a model of an LPP would look like. Great. Then the next part will be, let's come to some basic definitions. Okay, definitions. Okay, I may put it some important definitions or terminology. So there will be some terminology. Okay, so there are certain terms in this chapter that would be important, that would be completely new to you. So let's try to understand what are these. Okay, so the first definition will be feasible solution. So first definition is feasible solution. So what is the meaning of a feasible solution? So as you have in your notes, if you look at there, it is a set of values of the decision variables It is the set of the values of decision variables. By the way, x and y are called decision variables. Let me show you here. What are decision variables? If you want to know, then this is the decision variables here. This here, x and y in the equation. All these are called decision variables here. Okay, and LPP always has a decision variable. Great. So what is a feasible solution? A feasible solution are a set of values of the decision variable. That means all those values of x and y that will satisfy the constraints of an LPP. You know, an LPP has three parts: objective function, constraints, and non-negative restriction. Negative restriction. If you look at your definition there, so what is a feasible solution? Those set of values that satisfies the constraints. Constraint would mean this equation number 2 here. Those values that will satisfy all these constraints here is called feasible solution. Remember, our target or objective in a linear programming problem would be to optimize the objective function. So if you only find those values which will satisfy equation number 2, let's say in equation 2, then that is not your answer. So feasible solution is not your answer. Okay, feasible solution is not your actual answer. Feasible solutions are only the ones which will satisfy the constraints. Second one. Okay, so again I'll read it out. A set of values of decision variables which satisfies all the constraints of an LPP, including the non-negative restriction, by the way. Okay, so let me put it in different color. So those answers which will satisfy constraints and non-negative restriction, these two are called feasible solution. Okay, so now please remember the objective function is still left out. Now the second definition, the optimal solution. What is an optimal solution? The optimal solution is obtained from feasible solution. Let me read it out. A feasible solution which optimizes the objective function. That means those answers that are taken from the feasible solution here, and that selective answer which will optimize, which will help you reach your target, which will help you optimize the function. Let's say there can be hundreds of answers which will satisfy constraints and non-negative restriction, but out of those hundreds of answers, there is only one answer that will maximize or minimize, or in general, let's say optimize the objective function. So your actual answer is the optimal feasible solution, or the optimal solution. We also call it optimal feasible solution. Okay, so the actual answer you are looking for would be the optimal feasible solution. Okay, so you need to find the optimal feasible solution in the in an LPP. Okay, so that would be your target. So did you understand till here? So that is what I have. A quick recap would be linear programming problem is a mathematical technique which would help us to solve target-based problems, like I have shown you here: completing a project in 10 days, selling maximum amount of goods in a month, buying a smartphone within 10,000. This is target-based situations, okay? Because there are restrictions in this problem. What is the restriction in the first one? Time. Second one, time. The third one, money. So if this math problem, all these scenarios could be turned into mathematical problem, then solving this problem, what would be the method to solve this problem? Linear programming. We would use linear programming to solve this problem to achieve maximum output, or we say to optimize. Okay, so here we have the model of an LPP. I'll revise it again. So it has three parts: the objective function, the non-negative restriction that is given by 2, and the constraints that's given by 2, and the non-negative restriction given by 3. Okay, and some important definition that we come across: feasible solution would mean those answers which will satisfy 2 and 3. That means the constraints and the non-negative restriction. There can be many such answers, but the one which satisfies the objective function is called the optimal solution or optimal feasible solution. So finally, we are looking for an optimal feasible solution in every linear programming problem.